Here the next point is definite integral as a limit of sum. So we now show that definite integral is basically limit of certain summation expression. Okay. Now if you just recall, as I told you, definite integral from a to b of function fx, this represent area of certain region here, certain region here. So represent area of certain region. Which region? That is this region. You take two vertical lines starting from A, these are called limits, and ending at B. You have some function here, y equals to fx, this function, and with x-axis. So this is the region with area equals to this integral with modulus. This may be sometimes negative, but if we take modulus it becomes positive. So area of this region is given by this integral. Now what we'll do here is, to get this area, we divide, this is the procedure, I'm not getting into detail. We divide this region into number of strips here. One is this strip, second is this strip, third strip, and so on. So first I'll take n equal intervals. First we take n equal parts or intervals. Now what's the total length of this? That is b minus a. If this is 1, for example, and if this is 2, then total length is 2 minus 1. If this is 2 and 4, then 4 minus 2. So total length is b minus a. Now you are dividing in how many parts? N parts, remember. So what is the length of this part? It would be b minus a by n. We call this as h. Fine. So here length of each part is small h, which is given by total length divided how many parts? N parts upon n, where n is right now any integer. Suppose in the beginning you have taken 100 parts, so b minus a by 100. Suppose this is from 2 to 6, then 6 minus 2, so total length is 4 here, that way. Okay, so we have h. Then what we'll do here, this is the basic concept. Suppose you take the first strip as like a rectangle. You can imagine here like a rectangle. Okay, so to get the area of this rectangle, I need length and breadth, that is L into B. Now this much is h here. This much is this is h. Now height, suppose if this is x or this is a, then this is a plus h. So the y coordinate is f of a plus h. Height means y coordinate, that is this one. Fine. And so on. Then second strip, third strip, and so on. We add all these rectangles. So we'll get the entire region. Now to get this precise region, what we do? We take the very large number of intervals. So we take n tends to infinity here. Okay. N tends to infinity. That is, you are taking very large number of intervals. So this strip become very simple, small, remember, very small strip. And therefore this looks like a rectangle. Here actually a curve shape. But if I take very small interval, this looks like a rectangle. So if number of intervals are very large, then length of each interval becomes very small. That is, h tends to 0 here. So we have this concept also. When n tends to infinity, then naturally here h tends to 0. Okay. Now what I'll do, I'll find the length of area of each interval. So first interval area is h into f of a plus h. Then here it is h into f of a plus 2h. Next, that is this point, and so on. And then we'll add them. So last interval you can write h into f of, for example, a plus, you need n minus 1 point. So here I'll write n minus 1 h. These are all rectangles area. We have added them, and then what we do, we take very small length here, so h tends to 0, right? So each interval become very small, so each rectangle, if you imagine and then you add them, it becomes this curve shape. So this gives us what it gives us. This gives us the area of the shaded region, which is this definite integral a to b fx dx. This is what the general concept. This is just for your information I've explained, not important for examination point of view, because I'm going to write this as the next formula and we'll use these in every question. That's why I've stated. Here remember, this you need to keep in your mind. If n tends to infinity, this is very large number as I told you, so h tends to 0, h become very small, that tends to 0. What is h? That is b minus a by n, as I explained. Okay, now I'm just stating this as a definition of definite integral as a limit of a sum. So finally we have this you need to keep in your mind, integral a to b fx dx, that's given by limit h tends to 0. H I'll keep outside, that addition I'll express as a sigma I runs from 1 to n, f of a plus I h. If you take different values of I, and if you drop the sigma notation, you will get that expression. So this is the definition. This is called definite integral as a limit of this summation, remember. The same formula you can write in terms of infinity also. So I can rewrite like this, limit n tends to infinity. Here you can write the formula for h if you want to write b minus a by n, but I am keeping h as it is, sigma I runs from 1 to n, f of a plus ih, right? This you need to remember. The previous page, the beginning, what I've explained, that is just for your information, how we are writing this formula, that I've tried to explain, remember. For sums, this is important, remember, whether you write this or you write this, tends to 0 or tends to infinity, both are same. Normally, for polynomial questions, for polynomial functions, we use tends to infinity. We use tends to infinity. And for exponential or trig functions, we use normally h tends to 0. You can use either of them freely, that's not important, remember, but just I'm telling you. Polynomial means what? Like x squared, if you have 2x plus 1, something like this, then you can use tends to infinity. And if you have exponential, you know, e raised to x, 2 raised to x, trig, you know, if you have such functions, you should write tends to 0. Again, I'm saying it's not important because either of these two can be used freely depending upon the question. Okay, now we can go to exercises. That's exercise 7.8. But before I get into that, I'll just remind you 2-3 things from 11th standard. So just recall from 11th standard. One is this. If you remember, if I have sigma I runs from 1 to n I, that is what? 1 plus 2 plus 3 and so on up to n. Sum of the first n natural numbers. Put I equals to 1, 1. Sigma means plus. Put I equals to 2 and so on up to n. You know this. N by 2 into n plus 1. This is known to you. Very standard expression. Sum of first n natural numbers. You know it very well. Okay. One more. Just recall this. Let me recall. Sigma I runs from 1 to n I square. These also, you know, 1 square plus 2 square and so on up to n square. What is that? Can you recall? It is given by which expression? 11th standard, n by 6 into n plus 1 into 2n plus 1. I hope you know this. Okay. So, second important one is this. Third important one, that is sum of, one more is there, but that I'm not going to use. If you remember, 1 cube, 2 cube, n cube is also there. That's the square of this. But I don't want that here, so I'm not stating that. Sum of n terms of a geometric progression I have to write. N terms of a GP, geometric progression. Where first term is here, first term is small a, and ratio equals to, let me write small r. Then Sn is given by this formula, a into r raised to n minus 1 upon r minus 1. This is the formula, if you just recall, where r is not equals to 1, otherwise denominator becomes 0. This is also a standard formula for sum of n terms of a geometric progression, a into r raised to n minus 1 upon r minus 1. Fine. One more thing from limits, which I also did in 11th. If you just recall, limit x tends to 0, e raised to x minus 1 upon x is always 1. This should be equal and tends to 0, then the answer is 1. In fact, we had this formula, if you remember, limit x tends to 0, a raised to x minus 1 upon x. So answer is actually log a here to the base e. This was the formula, but that's not important. Here a is e, so log e to the base e, you know 1. We use this. Okay. If I have like this, for example, limit, suppose I have h tends to 0, this one, and this one should be same. If I write e raised to 2h minus 1, then I must have 2h, remember here. That should be noted here. We did it in supplementary material. These and this should be equal, then limit is again 1. Okay, so I hope with this information now we can go to first question in the exercise. Let's go to 7.8. I'll do question number 1 here, or let me go to 2 first. You have integral 0 to 5 x plus 1 dx. Okay. All are 3 markers, remember. So you see how I'm doing. You should follow exactly the way I'm doing. So which function you are given here? X plus 1. From where to where? 0 to 5, remember. So this is like closed interval AB, remember. Function is defined on this closed interval AB. A is 0, B is 5. Okay. I'll write h first here. Therefore h is equal to b minus a, length of this interval, 5 minus 0 by n. So you have h is equal to 5 by n. Keep inside, I'll call this as 1 because later on I'll use this. In every questions we'll use this concept, remember. Okay. Now we go to definition directly. So I'll write here by definition. I'll write by definition integral 0 to 5 fx dx equals to, you are going to just recall the definition. This is about polynomial functions. So I'll write h tends to 0. Even if your written tends to infinity, don't worry about it, doesn't make any difference. You can change it in the next step. I runs from 1 to n, f of a plus ih. This is the definition. Always you should write. Okay, now we just continue. This is basically now no more integration. This is some question of limit, remember. Sigma I runs from 1 to n. What is a here? 0. So this is f of ih. Fine. F of ih here because a is 0 here. Now what is fx here? X plus 1. So what is f of ih? Ih plus 1. So I'll write here ih plus 1. I have dropped one step. What is a? 0. So 0 plus ih, that is f of ih. What's the definition of function here? Just go to function x plus 1. So ih plus 1. Now we use the properties of sigma. What I'll do? I'll take sigma inside. Okay, so I'm getting here, this is equals to, let me continue here, limit h tends to 0, I'm just taking sigma inside the expression, remember. मैं sigma अंदर ले रहा हूँ. So h will come outside. H square sigma I runs from 1 to n I. Why I've taken that h outside? This h and this h gives us h square because sigma depends upon I only, remember. H into sigma I runs from 1 to n 1. Fine. I hope this is now clear to you. Limit is for both, remember. Okay. Now use the formula for this. I already stated. What's the formula for this? Limit h tends to 0. H squared as it is. You know the formula for this. N by 2 into n plus 1. You know it. What's the meaning of this here? I'm sorry. I should write like this. What's the meaning of this sigma 1? Sigma 1 means what? 1, 1, 1, 1. How many times? N times. Because you have I runs from 1 to n. 1 plus 1 plus 1. If you write 3 times, say 3. Here how many times you are writing? N times. So it is n. I've used indirectly this sigma 1 where I runs from 1 to n. You are doing n times. That's why it is n. If you are doing 20 times, it's 20. 1, 1, 1, 1, 20 times. So it's 20. Okay. Now, normally, you see power of n and h are always equal. So this you know by the equation 1. nh is 5. Now if you have h square, यहाँ पे भी n square ही होना चाहिए. So what I'll do this way. Limit h tends to 0. Here I'll take n outside one more. So this is n square. This is 1 plus 1 upon n. What I did? Taking n outside. क्या किया मैंने? n plus 1 में से मैं n बाहर ले रहा हूँ. So this is just 1 and this is 1 by n. So this will be 0 and here you have 1. So we have 1 plus 1 upon n upon 2 तो है ही plus hn या nh. Now by 1 you know nh. What is nh? Go back to 1, you will realize it is 5. So this is 5, this is 5 square. And now I should write, because 1 upon n is there, so I should write tends to infinity. So 5 square, 25, 1 plus 1 upon n, plus this is just 5 upon 2 is already there. Now apply the limit. As n tends to infinity, what is 1 upon n? Always 0. So you have 25 by 2, 1 plus 0 plus 5. What I've used here, I've used this concept. Probably I had explained this one in 11th standard. N tends to infinity. 1 upon n is always 0. It's quite obvious. If n is very large number, 1 upon very large number is very small. So this is 0, remember. So what we'll get finally? 10 plus 25, that is 35 by 2. This is the value of integral. This way you need to do. I could have written n tends to infinity from beginning also, remember. Does make a difference. You can write tends to infinity from beginning, or you can change if you required anywhere. So this is the value of integral. The integral was this, from 0 to 5 x plus 1 dx. You can do directly also, but here we did other limit of sum. I'll go to question number 3 here. I equals to integral 2 to 3 x square dx. Which function you are given? X square. On which domain? 2 to 3. A to b. Therefore, what is h? B minus a. 3 minus 2. 1 by n. Call this as 1. So nh is 1. That we will use. Okay. So now I'll write by definition. So now by definition, you have I equals to, I means given integral, limit, I'll write n tends to infinity, h into sigma, I runs from 1 to n, f of a plus ih. Now here integral is from where to where? 2 to 3. So here you have limit n tends to infinity, h into sigma I runs from 1 to n, Here a is 2, so this is f of 2 plus ih. Now what's the formula for function fx equals to x square? So 2 plus ih the whole square. So I'll write directly here 2 plus ih the whole square. I've used the formula for function, which is fx equals to x square. Now we want to take that sigma inside, but before we do that we need to expand this. So I runs from 1 to n. This is 4 plus 4ih plus I square h square. Okay, so this is limit n tends to infinity. You just take h inside and sigma also, so we are getting this 4 आप बाहर ले सकते because it is a constant. So 4h, if you are taking 4 outside, here you are just getting 1 plus here this 4h and h square, so 4h square outside, sigma I runs from 1 to n, I you know this, then plus your h square will come out, so here h cube, sigma I runs from 1 to n, I square. Okay, you know now this is 1 1 1 how many times? N times, so this is n. This also you know n by 2 n plus 1, we did this. These also you know are illustrated, so we place these values now. If I place these values here, this is limit n tends to infinity. This is 4hn, 4h square as it is, you know this is n into n plus 1 by 2 as I explained in the beginning, plus this h cube as it is here. What is this? N by 6 into, if you remember, n plus 1 into 2n plus 1. This is very standard formula, we know it. Okay. Now we do two things. Everywhere power of nh, h should be same. nh, you take n outside, n square, n from here, n from here. So if I do that here, limit n tends to infinity. For this nh I'll keep as it is. 4 by 2, this is just 2. Here you are left with 2. H square, I'm taking n outside. These n and these n gives us n square. So 1 plus 1 upon n plus n is there. One more from here, one more from here. So h cube, this is n cube. 1 plus 1 upon n into 2 plus 1 upon n. The whole by 6 is already there, remember. Okay, now we just put nh equals to 1, you know, by 1. From 1 you know nh is 1 here, so this is just 1. And as n tends to infinity, this is 0, this is 0, and this is 0. So I'm doing two things here. 4 into 1, this is 1 square into 1 plus 0. As n tends to infinity, 1 upon n is 0. This is 1, so 1 cube. This is 1 plus 0, 2 plus 0 by 6. Okay. And now finally 4 plus 2, 6, and this is 1 by 3. So 6 plus 1 upon 3. So you have 19 by 3. This is required integral. The value of the integral I is this, remember, 19 by 3. I've used this here, limit n tends to infinity, 1 upon n is always 0. It's quite obvious, we did it in 11th also. If n is very large number, 1 upon very large number is always tends to 0. Okay. Question number 5. It's about exponential function, minus 1 to 1 e raised to x dx. This is about exponential function. So here fx equals to e raised to x on minus 1 to 1. What is h here? H is b minus a. This minus this, remember. B minus a by n. So this is 2 by n, remember. So we can use nh equals to 2 later on. We call this as 1, nh. H is b minus a, so we'll get 2 by n. Okay. Now we write by definition integral I equals to limit, here you have exponential functions, I'm writing h tends to 0. H tends to 0, h into sigma I runs from 1 to n f of a plus ih. Okay, so this is limit h tends to 0, h into, what is a here? A is minus 1, first value. So you have f of here minus 1 plus ih. And what is this? What is fx? That is e raised to x. You know, here fx is e raised to x. So e raised to minus 1 plus ih. So e raised to minus 1 plus ih. Now, in such questions, if you have addition of exponents, you can write as a product. So I'm writing like this here. H into sigma I runs from 1 to n e raised to minus 1 into e raised to ih. You know, both the bases are same, you can add the exponent. Now this is constant, remember, 1 upon e you can write. So I'll take that outside. This is just 1 upon e, I'm keeping outside. Limit h tends to 0. This is h into sigma I runs from 1 to n e raised to ih. Now this is, if you just write one more step, you will realize that sigma is a geometric progression. Let me write that. If I drop the sigma notation, take I equals to 1 e raised to h, put I equals to 2, so e raised to 2h, put I equals to 3, e raised to 3h, and e raised to nh. You can just recall this is a geometric progression where a is the first term, e raised to h, this upon this, common ratio is also this upon this, which is e raised to h. So I'll use that Sn formula for a geometric progression. 1 upon e right now as it is. This is limit h tends to 0, h into, what's that formula? A into, a is e raised to h, r raised to n, that is e raised to h raised to n minus 1 upon r minus 1. R minus 1 means what? E raised to h minus 1. Which formula I've used? Sn equals to, I've used this formula. Sn equals to a into r raised to n minus 1 upon r minus 1, as I mentioned in the beginning. Okay, now the next step here. So this is equals to here 1 upon e constant. If you observe this much, this becomes a formula. E raised to h minus 1 upon h, limit h tends to 0, this h upon e raised to h minus 1, e raised to h, this one as it is, power of the power gets multiplied, so this is e raised to nh. What is nh? It is 2 if you remember, minus 1. nh equals to 2 I have used here, remember. I just explained, this is the standard formula, e raised to h as it is, power of the power gets multiplied, nh, what is nh? That's 2. You know that this is 1 here, as I stated earlier formula. So 1 upon e, this is 1, this is e raised to 0 and e square minus 1. So you are getting e square minus 1 upon e. This is the value of the integral. The integral was from where to where? Minus 1 to 1 e raised to x dx. This is by limit of a summation. Question number 6. One more question for you. Integral from 0 to 4 x plus polynomial e raised to 2x. So here a mixed function, polynomial and exponential. Okay, so I'll write here fx equals to x plus e raised to 2x on which domain? 0 to 4. Therefore, what is h? B minus a, that is 4 minus 0 by n. So you can write here nh equals to 4. Call this as 1. We use it later on. Okay. Now I'll write by definition integral from 0 to 4 fx dx equals to limit, you can write anything, tends to 0 or n tends to infinity. Then you can change it if you want. Suppose I'm writing h tends to 0, h into sigma I runs from 1 to n f of a plus ih. Here a is 0, so 0 plus ih. So just you have this. I have dropped one step here. A is 0, remember. A plus ih. You should not drop this in the exam. Okay. This is equals to limit h tends to 0, h into sigma I runs from 1 to n. What is fx? This one. So x is ih here. So ih plus e raised to 2ih. We have this. Now we'll take the sigma inside the bracket. So the next step is here. This is equals to limit h tends to 0. Outside it is h square. Sigma I runs from 1 to n I plus h is already outside. I runs from 1 to n. Here e raised to 2ih. You must have realized what I did after doing so many questions now. Just have taken sigma inside the bracket. That h, outside h and inside h gives us h square. Now you know this is the formula. So for this I need tends to infinity here. So I'll write n tends to infinity h square. What is this? That's a standard formula, you know. N by 2 into n plus 1. That you know, we did it number of times. Plus I'll write here. For exponential function I need tends to 0. So I'm writing h tends to 0. This h as it is. What is this? If you write one more step, you will realize this is a geometric progression here. I'll write one more step. Take I equals to 1, e raised to 2h. Take I equals to 2, 4h, and so on, e raised to 2nh. What I did, I've dropped the sigma notation, remember. This is a geometric progression. This is JP, remember. What's the first term? E raised to 2h. What's the common ratio? These upon this, which is also e raised to 2h. Okay. So here, finally, you know this h square and n square should have same power. So n tends to infinity. H square. I'll take n outside. Now this you know. So this is 1 plus 1 upon n by 2. Plus here limit h tends to 0. This h as it is. For geometric progression you need to use that Sn formula. What's that Sn formula? A into e raised to 2h a into r raised to n minus 1 upon here r minus 1, that is e raised to 2h minus 1. Previous question, what I did? A into r raised to n minus 1 upon r minus 1. Remember here a is e raised to 2h and r is also this term upon this term, which is e raised to 2h, and this is that Sn formula. Okay, now this is you know, beginning you just recall what is nh, it is 4, so this is 16 and this becomes 0. So this is 4 square, this is 4 square by 2, because this becomes 0. Let me write here 1 plus 0 so we can understand. Okay, this as n tends to infinity, 1 upon n tends to 0, plus, now here we need to set that formula. I'm just rearranging. Limit h tends to 0. This will always go in the formula, remember. So e raised to 2h minus 1. Now if your 2h, as I explained earlier, यहाँ पे भी 2h होना चाहिए. आपके पास h ही है. आप 2 से multiply कर रहे हैं, तो I need to write 1 by 2. You know it. This and this should be same. Now this will be just 1. You just recall as I explained in the beginning. What about this? E raised to 0. So this is e raised to 0. And power of the power gets multiplied. So this is nh. What is nh? 4. 4 into 2, that is 8. So e raised to 8 minus 1. I repeat this thing. See what I did here. This much will always set for the formula. So I need 2h over here because I have 2h. So into 2 by 2. As h tends to 0, this becomes 0 here. Power of the power gets multiplied. So this is nh. Just look at it 1. What is nh? 4. So 4 into 2, which is 8 minus 1. You know that this is 1 here. So finally, this is 8 plus, this is 1 into 1 by 2 into e raised to 8 minus 1. So therefore, 8 into 2, 16 minus 1, that is 15 plus e raised to 8 by 2. Right? This is the value of the integral. It was which integral? Integral from where to where? 0 to 4 fx dx. This is the required integral here. Two questions are for you. Question number 1 and 4. 1 and 4. First and fourth. These two questions for you. Try this. Not difficult. Both are about polynomials. Tends to infinity.